Hi, everyone. Thanks so much for joining us. Good morning. This is a Marine Technology Society member webinar, and I'm very excited today to be joined by Ryan Hannum from Flower Garden Bank's National Marine Sanctuary, who will be giving the presentation. I'll be your moderator. My name is Tosca Lichtenheld, and I lead Sofar Ocean's government business. For those of you who aren't familiar with Sofar Ocean, we're an ocean tech startup on a goal to close the ocean data gap. And our company's mission is to connect the world's oceans to power a more sustainable future. And the main way that we're doing that is reducing the cost and complexity of ocean sensing. And so I'm really excited to be working with a number of different partners, including NOAA, including the Flower Garden Bank's National Marine Sanctuary, the Army Corps of Engineers, the US GS, and all of them have ocean sensing needs. As you know, there's a lot more data collected over the land compared to over the ocean. And so we're excited to be able to support in helping to close that ocean data gap. Before we dive in, I do just want to give everyone a brief overview of GoToWebinar. As a reminder, this session is being recorded. If you have any questions for myself or for Ryan, or if you're having any technical issues, please feel free to type them into the chat box. You should see that on your right-hand side where it says questions, and we will be able to address those pretty promptly. We'll also leave time at the end for the questions that you have for Ryan. So we'll make it a little bit of a Q&A session towards the end of this webinar. Without further ado, I'm very excited to introduce Ryan Hannum. Ryan joined the Flower Garden Bank's National Marine Sanctuary team as a contracted employee with Cardinal Point Captains in 2021 to lead long-term monitoring efforts. His expertise is in water quality monitoring and data management, though he also contributes to a variety of other sanctuary projects, as you'll see in this presentation, such as the Mooring Buoy program. Prior to joining Flower Garden Banks full-time, Ryan was a volunteer scientific diver at the Marine Sanctuary, while also conducting coral conservation biology at the aquarium at Moody Gardens. While there, he housed and cared for 100 coral colonies as a partnered member of the Florida Reef Tract Rescue Project. Ryan obtained his Bachelor of Science in Biology at Oregon State University. All right, Ryan, over to you.
All right, thank you, Tosca, and thank you to Sofar and MTS for putting all this together and setting up hopefully what will be a wonderful presentation. But again, my name is Ryan Hannum. I'm a contracted research specialist for the Flower Garden Bank's National Marine Sanctuary, and I'm excited to share a little bit of what we do within our sanctuary and some of the activities that we get to participate in, especially as we're about to kick off our summer season. So the first thing I want to do is kind of go a little bit more big picture and just briefly touch on what are the marine sanctuaries. So what the Office of National Marine Sanctuaries falls under the National Oceanic and Atmospheric Administration, or NOAA, and kind of the best way or the easiest way to describe what a national marine sanctuary is we're really just the national parks of the oceans. So we're sites that have been designated by the federal government that can be used for recreational purposes for all US citizens. We can find up to 15 national marine sanctuaries throughout the US and its territories. And at these sites, you can either experience shipwrecks, experience whale migrations, you can go dive kelp forests on the west coast of California, or you can dive and enjoy the coral reefs of the more tropical areas. We also have 2 marine national monuments out in Papahanao, Makuakea, as well as Rose Atoll near American Samoa. And we currently have 6 new sites up for designation. So we're very excited to see a lot of expansion being taken place in protecting our oceans. But for this presentation, I wanted to hone in specifically on the Flower Garden Banks, which is located in the northwestern part of the Gulf of Mexico. We are the only marine sanctuary in the Gulf of Mexico, with our nearest sister sanctuary being the Florida Keys National Marine Sanctuary. And ours is located roughly 70 to 120 miles offshore the coast of Texas, which is where our headquarters is located in Galveston. And you can see in the smaller map up in the left corner, that little white dot kind of designating where Houston is. So we're a good fair bit offshore. Our sanctuary was designated originally just 2 of our 17 banks back in 1992, starting with the East Flower Garden Bank and West Flower Garden Bank. In 1996, we expanded to add Stetson Bank up here in the northwestern part of the sanctuary boundaries. And then in 2021, recently in the last 3 years, we've expanded to add the other 14 banks into the sanctuary that you see now. So we're one of the smaller sanctuaries at 161 square nautical miles. And we're kind of split up into different areas, which would require some transit time to go from one bank to the next. So diving in a little bit deeper, the 3 sites that we primarily visit are our earlier designated sites, East Flower Garden Bank, West Flower Garden Bank, and Stetson Bank. At these 3 sites, you would find on the surface a series of vessel mooring buoys so that vessels can tie up and use the sanctuary, since we don't allow anchoring because we're predominantly a coral reef site. So these buoys allow for infrastructure not only for us, but for other vessels. We also have a few moored data sondes along our reef crest. Our reef starts at 16 meters, which is where you can find our primary data sondes, which measure temperature, conductivity, and turbidity. But we also have some deeper temperature loggers at 30 and 40 meters just alongside the bank, the edge of the banks. We also, you can see in the black squares at East and West Flower Garden Banks, these are our long-term monitoring sites. These are where we do the bulk of our photogrammetry work, taking pictures of, repetitive corals that we have time series over spanning, 20 to 30 years for a single coral, as well as looking at coral coverage and coral biodiversity through random transects. And then the last kind of piece that you can see on that East Flower Garden Banks, that star is currently where our Sofar buoy is located and has been, sitting there for nearly a year now, I think 11 months. So what are the things that you can see at our sanctuary? Well, the first thing you'll see when you dive in is just the amount of coral that we have. At both East Flower Garden Bank and West Flower Garden Bank, our average coral cover is roughly 50 to 60%, with only 20% going to algae. So we are a very coral dense reef environment, which we attribute to our remoteness as well as our added depth compared to shallower coastal coral reefs that have more direct contact with sun and have more rapid heating in the summer seasons. But while you're down there, you can also, enjoy a lot of our fish species and our charismatic species, such as our manta rays. So the Flower Garden Banks is a manta ray nursery. So we see a lot of juveniles there, as well as seeing sharks, turtles, and on the very rare occasion, whale sharks will pass through our sanctuary. Some of the research that we do that I mentioned, the photogrammetry that you can see in the top right photo with our diver, doing some random transect photos. This is what helps us determine our coral coverage throughout our sanctuary. But as you get deeper into our mesophotic depths, starting at 150 feet, you can see those bouldering stony corals transition more into octocorals and black corals. Now, our sanctuary, the Flower Garden Banks, isn't just a coral reef site. We also have other unique features, including basalt spires, mud volcanoes, and a brine seep. And for those that aren't familiar with brine seeps, it's areas where pocketed high salinity water forms and it looks like an underwater lake. So how do we get access to this remote site 100 miles offshore? Well, our sanctuary has our own vessel, the RV Manta, and this is a 86-foot twin hull jet engine vessel that can house 14 people, including a 4-man crew and up to 10 divers. This takes us about 10 to 12 hours to get offshore and is a great vessel for both or utilizing ROVs on the back deck using our hydraulic A-frame winch. Now, don't let this calm sea state fool you. This is, some of the times, but definitely not all of the time. A lot of times, in fact, weather will get weathered out in which we can't go offshore because we can get, winds up to 20 or 30 knots, and we can get wave heights up to 20 feet. Now, on top of that, there's also the issue of vessel maintenance. So sometimes our vessel, something will break, it needs to get repaired. Every year we go through maintenances, which can at times take a little bit of time to get those repairs done and limits our window of opportunity to go offshore. And even if the weather is correct and the boat is working, sometimes we don't even have the divers on staff to man a 5-day cruise operation. So while we're hopeful to get offshore, and we do get offshore for a number of weeks each year, we're very limited due to the remoteness of the site. So one of the ways that we can kind of manage our data stream, since a lot of our moored instruments, we have to go out and recover those, it's beneficial if we have something that utilizes telemetry so we can at least get some data in between. In the past, we worked with Texas A&M's Geochemical and Environmental Research Group, who managed the Texas Automated Buoy System, or TABS. And this was a way that we were getting sea surface conditions, we were getting sea surface temperature in real time. That was a great kind of buffer for those times where we were unable to go recover and retrieve the data from our sondes deployed at the reef site. Unfortunately, due to policy reasons, these buoys were removed in 2019, which has left a big data gap for us and is now requiring us to solely rely on those moored instruments. So last year was a great example of this. We, at the time, didn't have any telemetry just yet, so we were relying on those loggers. And we had recovered our loggers up until August 18th. After that, we have not even yet been able to go and retrieve those loggers to finish out last year's data series, in this case, the East Flower Garden Bank temperature series. So we've had to rely on satellite sea surface temperatures to get a better understanding of what those temperatures look like out at the sanctuary. Now, for a site that's, starts at 16 meters and those data sondes start at 23 meters, we know that the temperature that the reef crest is experiencing is not necessarily the same as what the surface is experiencing. So we don't have exactly accurate data. We have a good estimate, but we needed that ground truthing component to really have an idea of what our corals are dealing with from a heat stress comparison. You can see from this, our temperature threshold is at 30 degrees Celsius. And from the satellite component, we had 30 consecutive days above our temperature threshold where we would start to observe bleaching within our corals. But again, that was sea surface, and we really needed to know what those temperatures looked like at depth. So in comes the Sofar buoy, which was the spotter buoy along with the smart mooring system, which was purchased for us on behalf of the National Marine Sanctuary Foundation and has been a great tool that we've been able to use since its deployment. We've really enjoyed that it's a small device, a little bit bigger than the size of a basketball, and was something that we were able to deploy using divers. So we ended up deploying this on a railroad wheel, which you can see there in the middle, which is actually the same anchor site that our old TABS buoy was used. So we already had the infrastructure in place. All we needed to do was just get it hooked up, turn it on, and it was ready to go. And since we've had it on and going, we've not only for the temperature data that we desperately needed in real time to monitor for coral bleaching events, in which we did have a little bit of coral bleaching last year, but we also really like and utilize the sea surface conditions that the spotter buoy provides for our ability to assess whether it's safe or not to go out in transit and be out there for a few days. Ultimately, we rely on forecast models, but it's nice to have a ground truthing component that we can utilize to make sure that those models are looking right and that it is safe for us to navigate out there. So now coming back to that same graph, this time with the Sofar buoy data overlaid onto it, we can finally round out our data for last year's temperature. We were able to get some ground truthing to compare to the satellite sea surface temperature, which was pretty spot on. But then having that reef crest temperature sensor was a great tool because we can see that differentiation between the surface temperature and that at the reef crest. So that 30 consecutive days above the bleaching threshold was actually reduced by half, in which those temperatures were, getting close. They were in the 28, 29 degrees Celsius, but that period over 30 degrees Celsius was significantly reduced, which is great. We still had a little bit of bleaching, but it wasn't as significant as we were fearing up until that point. So what do we do with the data other than, just looking at it and, fingers crossed and hoping our corals survive the heat? We also incorporate it into our own dashboard system, which is created in partnership with Dr. Dan Onis from the University of South Florida. And a lot of this comes also with information that we get from ERDAP and a lot of the satellite information, which creates, these beautiful images of the Gulf of Mexico. But again, we can attach that with a little bit of ground truthing by utilizing the Sofar buoy and having that real-time data stream as a comparison. We also use this data for our own monitoring documents. Every year we come out with long-term monitoring reports, the state of conditions for the sanctuary that year, as well as climate vulnerability reports that you can access these on our website, the Flower Garden Banks, at noaa.gov, my apologies. But then we also want to expand that out to other areas so they can utilize our data as well, including Aqualink, the Gulf of Mexico Ocean Observing System, or GCUS, the National Center for Environmental Information, which is where our data is being archived for download as well as, supplying our data to the Coral Reef Watch, the Tropical Analysis Forecast Branch, and finally the National Hurricane Center, which I will touch on in a moment. It's really cool what they're using our data for. But one of the biggest things that we want to make sure that our data gets out to is to the general public. Again, as a national marine sanctuary, we are similar to the national parks of the ocean. And so recreation is a big component of why we're there, how citizens can utilize this area and this resource for their enjoyment, in some cases for commercial reasons, such as commercial diving, and just for being available and having these sites for hopefully generations to come. And again, the spotter buoy and the information of sea state conditions is a big bonus for them as well, for these, especially these smaller vessels, these 35, 40-foot vessels that are making those transit out there. They want to have up-to-date information. And now with a lot of vessels having Starlink, they can get that data while they're out there and assessing weather conditions at a moment's notice. So these are two of the most common types of vessels that we see at the sanctuary, the top one being a typical recreational vessel looking to do some fishing within the sanctuary, and the lower one being the commercial diving vessel, the MV Fling, which can hold up to 30 divers on a trip. All right, and then kind of coming back again, I wanted to talk on the Tropical Analysis and Forecast Branch, as well as the National Hurricane Center. This is the organization, the agency that monitors and provides forecasts, up to 6-day forecasts for wind and wave conditions within the Gulf of Mexico, the Caribbean, and the Pacific side of Mexico. Now they have up to 10 million square nautical miles that they are trying to cover and get those predictive forecasts for. And while they're mainly relying on satellite data, as you can see in the image to the right, there are quite a few number of gaps as those satellites are passing over. And what we've learned is that they actually have figured out how to utilize Sofar buoys, ours included, that provide public information, that the data is publicly available, so that they can help fill in a lot of those gaps, especially, in the instance here in the Gulf of Mexico where the satellite isn't located. They can use our SOFAR system, use the wind and wave data to help supplement their forecasts so that everyone can have those. And especially as we're going into hurricane season here soon, those tools are going to be essential for not only them to use, but for everyone to have available. And then the last thing I wanted to touch on and how we use our SOFAR system and how our partners use the SOFAR system is our partners at Texas A&M Corpus Christi. Now, the graphs that I have displayed up here are part of a publication that's currently in review, so I highly encourage that everyone seek that out once the publication has been approved. But these were a few graphs that they were willing to share with me, to share with all of you, looking at ocean carbonate and mixed layer depths. So one of the things that they've been able to look at and compare using the hybrid ocean coordinate model, or HICOM, is that the mixed layer depths within the sanctuary are very shallow during the summer periods, shallower than what our reef crests are at. And what they've noticed using the SOFAR system and the smart moorings with our 2 temperature loggers is that there is a significant discrepancy between the temperature at the surface and the temperature at reef in that bottom graph, where we're seeing fluctuations anywhere between 1 to 2.5 degrees Celsius difference between those 2 sensors, which leads me back a little bit to talking about the satellites and how we knew that the sea surface temperatures using satellites was going to be different than what we expected on the reef crest. But some of the other research that they've been working on is looking at ocean acidification and ocean carbonates. So they've been looking at the carbon dioxide levels along the reef using their own deployed sensors that we coordinate with their deployments. And they've seen in the summertime an increase in carbon dioxide during this shallow mixed layer depth, as well as a decrease in the pH, which would make sense. Increase in CO2 would lead to acidification. But what they were also seeing, and I have that on the next slide, is a decrease in oxygen. So with an increase of CO2, decrease in oxygen, we're seeing suggests that that's a metabolic driven ecosystem during the summer. So the reef, the corals, the fish, all those animals are respiring, they're giving off CO2, but since that mixed layer depth is so shallow, there's no sea to gas interface that's allowing for the release of that CO2 into the atmosphere, as well as the uptake into that oxygen. But as the temperatures get cooler, that mixing depth gets lower and deeper into the water, we see all of these parameters start to level out. Now, working with Texas A&M Corpus Christi and helping with this research progress further, we've actually done a joint application to get some more SOFAR buoys. The first one coming through the Bristlemouth program, which we were awarded an additional SOFAR buoy and smart mooring, but also were able to acquire one of the Bristlemouth technologies, which will allow us to integrate and observe a optical dissolved oxygen sensor. So we hope to now, in addition to temperature, start getting dissolved oxygen sensors incorporated into our smart mooring system to not only allow us to monitor for heat threats, but also to start addressing the acidification and carbonate side of the threats that reefs are experiencing. We were also able to partner with GCUS, the Gulf of Mexico Coastal Observing System, to fund an additional 5 spotter buoys and smart mooring systems so that we can expand this out into more of the remote parts of the sanctuary on the eastern side, as well as having a few backups available for hot swaps if cords get broke due to prop cuts, storms are able to rip off those cables. So we'll have a few backups in hand. So what we hope the sanctuary looks like in the future with a few more spots. The first one, the original, was deployed at East Flower Garden Banks. We're hoping to, in the next year or two, expand that out to having 4 sites with Sofar buoys, including our 3 primary sites, including West Flower Garden Bank and Stetson Bank, but to start also expanding into the eastern parts of the sanctuary, beginning with Bright Bank. So we're very excited to be building the fleet of small yellow buoys, and we're hoping that that data will expand and be additionally more impactful, not only for us, but for our partners as well. So I want to say thank you so much to Sofar and to MTS again for putting all this together, as well as helping us set up our Sofar system. And then to all of our partners that have helped us to expand out and get this information into the hands of people that need it, as well as to the general public for their own safety and their enjoyment of our sanctuaries. So thank you.
Thank you, Ryan. That was a fantastic overview. For those of you who are listening, if you have any questions for Ryan, please feel free to drop them into the chat or into the question box, and we'll get them. To kick things off, Ryan, can you tell us a little bit more about the water quality monitoring program and what parameters are most important as part of that program and how long it's been going on?
Sure. So I only touched on, our long-term monitoring and our deployed sensors. Our primary data sonde will monitor for temperature, conductivity or salinity, as well as turbidity. And then we have some deeper temperature loggers that are just focused on temperature as well. But we also do profiles aboard the Manta, in which we expand out to include pH, chlorophyll, and PAR, I believe. And then we also take water samples. So we're also testing for organic compounds, nitrogens, phosphates, and chlorophyll. And that's just with in-house. That's stuff that we analyze, but we also work with partners. So we work with Texas A&M Corpus Christi to get water samples to help supplement their ocean carbonate studies. And then we also help with, Texas A&M and some local look at microplastics. So while not things we necessarily focus on, but we utilize partners and experts within the research industry to kind of help supplement and round out our research efforts.
Awesome, thank you. Another question that came in was around biofouling. Are you seeing a lot of biofouling on your instruments, including the Sofar buoy, and how do you manage that? And does it affect the kind of data you're able to get?
We do get biofouling. Only being 23 meters, our turbidity levels are low, so light penetration is quite good all the way down to the reef bank. For our deployed sensors, for the ones that are out there for a number of months, yes, they do come back quite biofouled and encrusted with crustose coralline algae, sometimes even small coral colonies. And we acknowledge and accept that there's going to be some drift in those, which again, at least for temperature components, makes the Sofar system even more integral because that data is coming in live. We're able to get what we feel confident is accurate data. But for the Sofar system, at least, whenever time we go out there, we will deploy divers that will go and wipe down those sensors using microfiber towels or soft brushes. We don't want to damage the sensors themselves, but we do want to get that fine biofouling off and make sure that those sensors are reading clearly.
Great, thank you. And then one last question. There's a question around if you're seeing hypoxia on the banks and if you're seeing correlation between the temperature readings that you're seeing and some of the other water quality parameters that you've been able to measure.
So addressing the hypoxia situation, we've not experienced widespread hypoxia across the banks. However, there was in 2016 one event that we've typically just classified as the mortality event, which was incredibly localized down to a single sand patch, and then up about 3 or 4 feet from that sand patch that, there was a mortality event. We believe that, there's a few papers that have come out that could suggest a hypoxic event. While there's also been speculation that it could be through a crevice or a fracture in the reefs are built on. It could have been an extrusion of highly saline water. When you observe the mortality event, at least the old photos from in 2016, there was a very defined line in which everything below that line, corals, for the most part, from our viewpoint, the corals had all perished, and then everything above that was still alive. So it could be a hypoxic event. It also could be salt intrusion. As far as looking at temperature and affecting some others, obviously the process of ocean carbonates is fairly impacted by temperature. We know that pH is impacted by temperature, oxygen is impacted by temperature. So a lot of these things are being driven by those factors that we believe are, temperature being the predominant factor for that. But again, that more falls into the expertise of our partners. So I can certainly, if there's more questions, I can link people up with our experts at Texas A&M Corpus Christi who do a lot more work on that.
Thanks so much, Ryan. Well, we are out of time. I do want to thank Marine Technology Society again for allowing us to host this webinar. I really want to thank Ryan for the amazing presentation. I learned a lot, so I was very excited about that. And for those of you who might have additional questions, you can reach out to me if you have questions about the Sofar spotter buoy. You can reach out to Ryan if you have questions about the Flower Garden Banks and the programs that they're running there. And without further ado, we will close this out. Thanks so much, everyone.